This is Jody Trana with Chapter 11, Part 2 of Business Finance. These are the capital budgeting evaluation tools that we're concentrating on in this chapter. Net present value, profitability index, internal rate of return, payback period, and discounted payback period. During the last class, we really concentrated on the net present value and the internal rate of return. You can see based on this graph that those two are methods that are used most often by CFOs who are making decisions. The internal rate of return is probably just a slightly better model because it is a rate. It is a ratio that can then be compared with other companies or other projects. The net present value is going to net a dollar amount, which sometimes can be very helpful. Those two methods are used a little more often because they use a discount percentage that will help you identify whether this really fits in with your other investment projects or not. As you'll find today, the payback period, discounted payback period, and profitability index are somewhat easy to calculate, but they may not always be the easiest to use to compare one project to another. Sometimes companies are trying to determine which projects they should take on, and they can take on as many projects as are profitable. And sometimes companies are trying to decide between one project or another, or one solution and another. Here we have a scenario where Apex Engineering is going to purchase an accounting system. Both systems cost the same. As you can see in year 0, they both cost $10,000, but their paybacks are very different. We are told that Apex requires a 10% rate of return. So the first thing that we want to do is to calculate the net present value. Remember that coming up with the net present value is a two-step process. We need to start first by calculating the present value of the cash flow streams and then comparing that present value against the initial cash outlay. So let's do that first. Here we can see the present value of each of our different project options. System X has a present value of $10,788, and System Y has a present value of $11,004. Now we can calculate our net present value by subtracting the initial cash outlay in year 0 from these amounts. The net present value helps us determine whether the project is a good project or not. We're basically looking for a positive number. In fact, even 0 net present value would give us the required 10% return that we want. So since we will accept anything above 0, we can now use the net present value to try and figure out which system will give us the better return. When we're just looking at dollar amounts, the net present value for System Y is higher at $1,004. But let's not just look at the net present value. Let's also look at the IRR. Remember that the internal rate of return is the rate of return that makes the cash inflows, the year 1 through 4 inflows, equal to the outflows of the $10,000. Or you can think of it as the rate necessary to produce a net present value of 0. The IRR needs to be compared to the discount rate. So that can make it kind of difficult if you don't know the discount rate. If the IRR is higher than the discount rate, it's a good project to pursue. So anything above 10% is going to be a good project. we know it's above 10% because our net present value is above 0. Another way to look at it, if the IRR of a project is greater than or equal to the project's cost of capital, we will accept the project. But if the IRR is less than the project's cost of capital, we're going to reject the project. Here's the rationale. You never want to take on a project for your company that returns less money to you than you're paying to borrow. That's your cost of capital. Let's take a look at the IRR. First, let's take a look at System X. You can see that when you calculate the net present value, and since these are mutually exclusive projects, meaning we're going to choose one over the other, System X loses. It has a lower net present value than System Y, so the firm would choose System Y over System X. But if you use the online calculator and you plug the cash flows for the two projects into it, the internal rate of return for System X is 14.49. Now let's look at System Y. System Y is the project you would choose under the net present value criteria, as its net present value is 1,004 as compared to System X's net present value of 788. But again, if you use the calculator and calculate your internal rate of return, you'll get 13.55. Under the IRR decision criteria, System Y has a lower IRR, and the firm would choose System X. So why does the decision criteria of internal rate of return and net present value give different answers in this analysis? This is one of the problems with internal rate of return in capital budgeting. At least when a company is using mutually exclusive projects, when they're trying to choose one over the other. Sometimes the IRR and the net present value can give conflicting decisions. It can also happen if any of the cash flows from a project are negative, except the initial investment. You can see here that with System X, the cash flows start large and end small. And it's just the opposite with System Y. The cash flows start small and end big. This is how we end up with different internal rates of return. Your company would need to know what decision criteria they choose and make the decision based on that. Either way, both of these are good projects. You would just have to decide which one you wanted. Next, we're going to talk about the profitability index. This is another way to analyze projects. To do this, we're going to take the present value of the future cash flows, and we're going to divide that by the initial investment. This gives us a ratio or a relationship between the amount of cost, initial cash outlay, compared to the present value that you will earn from that project. Let's first look at System X. To determine the profitability index, we will take the present value of the future cash flows, that's our 10,788 number, and divide that by the initial cash outlay of $10,000. In this scenario, our profitability index would be 1.078. To make a decision on profitability index, we are looking for any number that is above 1. I should say 1 or above, because we want a project that at least has enough present value to cover the initial cash outlay. For System Y, we would take $11,004 divided by 10,000. This profitability index is 1.1. Again, it's over 1, so that would be a good indication. And if it was our policy to do so, we could compare these profitability indices and identify system Y as a larger number. So why are we using the profitability index instead of just looking at the dollar amounts? One reason is so that these indices can be compared across projects and can also be compared across other companies or even industries. Now let's take a look at a pretty basic evaluation tool, the payback period. The payback period for an investment opportunity is the number of years that it needs in order to recover the initial cash outlay. That's it. We basically accept the project if the payback period is less than some predetermined number of years. So here's an example. After making a $20,000 initial cash investment, a project produces $10,000 per year, and the company requires a 2-year payback period. Do we accept the project? Yes, we do. The $20,000 is recouped in 2 years with that $10,000 per year production. Now, the payback period does not take time value of money into consideration, so it has some limitations, but it's pretty simple, and a lot of people use it as just an initial go or no-go decision on investments. Here we're going to take a look at an example for Southwest Systems where they're considering 2 different projects, and they're looking based on the payback period. So here you can see that management requires a 3-year payback. So they're going to make their decision solely on the fact of whether the project will pay back its initial cash outlay within a 3-year time frame. Starting with the long project, we can see that the payback comes within year 2. The initial cash outlay was $100,000, but in year 1, they earned back $70,000 of that to leave $30,000 of that cash flow still left to accumulate. Year 2 produces that $30,000, and so the payback is realized in year 2. The interesting thing about this long project is that the cash keeps flowing after the payback period. So in year 3, we have an additional $30,000 generated. In year 4, another $25,000, and year 5, another $10,000. So that project will accumulate $65,000 above and beyond the initial cash outlay. So not only does it meet our criteria of requiring a 3-year payback, but it also will generate more money. Taking a look at the shorter project, we can see that the payback period is the exact same as the long project. And with a required 3-year payback, this project also meets the criteria. Even though the long project looks a lot better, both of these projects will meet the criterion of Southwest Systems. So the payback period method doesn't always consider everything that you need for decision making. It doesn't account for the time value of money, and it doesn't account for future cash that may be generated beyond the payback period. Still, it is such an easy and simple method that it can really help to weed out projects such as this, where we can look at it and say, they both meet the criterion, but we're not even going to consider the short project anymore. And finally, let's talk about the discounted payback period. This combines a couple of philosophies that we've already talked about. That is identifying a payback period, which is similar to what we've talked about before, but we're going to use discounted cash flows. This will then take into consideration the time value of money. Let's take a look at Southwest Systems' short project and take the time value of money into consideration. Here we have the analysis that we did before that showed the payback period comes in year 2 with this project, but there's no additional cash flow. With the discounted payback method, we would do the same calculations, but with a discounted cash flow based on the time value of money. As you can see, year 1, rather than it being worth $50,000, is really discounted back to only $42,735, and year 2's $50,000 today is really only worth $38,000. So you can see that this project never really does have a payback if we use the discounted payback method. The same criteria would be used if we were to do the discounted payback for the long project for Southwest Systems. Again, the company would determine that they would need to collect or to have a payback based on a certain time period, such as 2 or 3 years, and then you would calculate the new payoff, and if it meets the criterion, then it's a go.